Everyone. Today we're going to be talking about a couple different things with solving equations. The first part of this video is going to address why it is that we use the inverse. Why do we use the inverse in order to solve these equations? And then the second half of the video is going to go through some examples where we solve equations involving decimal numbers. So first up, whenever we're solving an equation, that equal sign there means we're balanced. So in this example here, we have x plus 20 is equal to 45. That means the x, so our unknown value, plus 20 is that same amount. It is equal to the 45. And so in order to solve this equation, we focused on doing the inverse operations. An inverse is another name for opposite. So addition and subtraction are inverses, they're opposites of each other, and multiplication and division are inverses. Let's go ahead and go over to a website called GeoGebra real quick, so that way we can actually see a moving scale and better understand why doing the inverse is going to keep things balanced and help us solve our equation. All right, here we have a task on GeoGebra, and it gives us an equation, and then we're able to physically add things to the scale to see whether or not it's correct. So on the left-hand side, we have m plus 1. So we have m, and then we have 1 extra weight, and that is equal to 3 on the other side. We now have a balanced equation. These two sides weigh the same, they're equal. But if we're trying to get that m by itself, well, in order to get that m by itself, we need to take this 1 extra weight away. We need to subtract that 1. Well, if we subtract it, we're now no longer balanced. So that means we would also need to subtract it from the other side, giving us a balanced equation and showing us that in order for this to be a true statement, our variable m must be the value of 2. And then the cool thing is this website shows you how that works mathematically down below. And you can always try a few more. There's not a ton of examples on here, but you could always use this and create your own if you like it. So let's try one like this. M plus 2 equals 4. Well, we have m plus 2 weights on one side, and then we have 4 on the other side. It's a balanced equation. Well, if we want to try to get that m by itself so we can figure out its value, we would need to take these 2 weights away. We would need to subtract them. That's the opposite of a plus 2, subtraction. If we remove those 2 weights, it's unbalanced, so we must remove them from the other side, showing us that our answer would be 2. Okay. So hopefully that visual helped you. That's one way for you to kind of see why you need to do the same thing to both sides, why we're doing the opposite, the inverse, because that's taking it away, but we have to do it from both sides to keep things balanced. Let's check it out using a different scenario. All right, second way I like to think of the reason we use the inverse is you're packing a box, or maybe you want to think of it as you're wrapping up a present. But if you're packing up a box, if you're moving, first thing is you're going to get your box. Okay, you're going to open it up, and then you're going to put the items inside. So if we are putting these clothes in the box, we can see that the clothes go first, and then the glasses are sitting right on top. We could close the box up, take it to our new house, but then when we go to unpack the box, things are going to be in the opposite order, because when we pack the box, we open, put the clothes in, put the glasses in, tape it shut. Now, if we're going to unpack, it's all going to be backwards. First, we got to cut it open. We got to remove that tape. Then we take the glasses off the top. Then we take the clothes out. And now we have an empty box. So that's another reason why we do the inverse, is because we're undoing things. So it's now going to be in that opposite order of the way we started. And then lastly, let's look at why this really works mathematically. So when we're talking about inverse, when we're doing the opposite, it always clears it. Sometimes you'll hear teachers say it cancels out or it zeroes out. So the opposite of a 5 here would be subtracting 5. Well, 5 minus 5 is 0. So that's now taken away, that's canceled out. And then if we started with a negative 10 or a minus 10, the inverse of that is adding. Well, negative 10 plus 10 gives us 0. So once again, it goes away. Now multiplication and divisions are opposite of each other. So 4 divided by 4 is 1. And if we're just left with 1 of something, that's okay. We're just trying to find that 1 value or that 1 y value. So that cancels out by equaling 1. And then when we have multiplication and division, again, they're opposites of each other. Remember, this fraction of 1/3 here is the same thing as saying 1 divided by 3. So if we have division, we need to do the opposite, which is multiplication to cancel it out. If we do that, we get 3/3. 3 divided by 3 is 1. And look at that, it cleared. So that's why mathematically the inverse works, is because that clears it from one side of the equation, but then to keep it balanced, we have to do it to the other side, and we're moving it over to the other side of the equation. All right, I hope that kind of helped give you a better understanding as to why we're doing the opposite of things while we're doing the inverse when we solve equations. Now let's get into some practice. All right, so from this point on, I'm going to be practicing on how to solve equations with decimals, and there will be a lot of negatives involved because I know that can be a tricky part too. So I wanted to kind of combine that so we could practice both the negatives and the decimals. We're going to do 5 different examples together so we can see a good variety and use all of our different inverse operations. So when I see this equation, the first thing I notice is those parentheses. And I don't like those being there. It kind of clogs things up. So we want to see if there's anything we can do to get rid of those parentheses. And in fact, there is. We can simplify. Because these parentheses in this problem are grouping our negative with that number. It's kind of helping us determine that this is a subtraction sign and this is a negative. It's just trying to make it a little bit more clear for you. But that's not simplified. That's not the way we want to write things. What happens when you subtract a negative, when you have minus a negative? They cancel each other out because that minus is saying you go this way, but then that negative is saying, uh-oh, hold up, you do the opposite. So that way on the number line would be positive. And hopefully my camera here isn't mirrored. If it is, then my hand signals might have been backwards, but I hope you got the gist. Or if you think about it like you're playing an Uno game and somebody plays a reverse card, but then the next person plays a reverse again, that double reverse cancels each other out. So we can rewrite this problem as -2 4/10 is equal to x plus 12 8/10. Now that we've rewritten this, we can go about the business of solving for our equations, in this case, solving for x, and we're going to do that by performing inverse operations. I like to draw a line through my equal sign. It kind of helps me remember that balance, helps me make sure I do the same thing to both sides. Well, in order to move this plus 12 8/10 over to the other side, so our x can be isolated, our x can be alone, we have to do the inverse. The inverse of addition is subtraction. The inverse of that positive is a negative. So we're going to subtract 12 8/10 from both sides. If I go ahead and do it from the right side first, that 12 8/10 minus 12 8/10 equals 0, because when you subtract the same thing from itself, it cancels out and is 0, and we're simply just left with our x. You could even draw a cute little z through it to say, hey, this zeroes out. Now we need to focus on the other side. This is where, your negatives could trip you up. So please continue to work with them, practice, and try it on your own first. But then if you do make a mistake or you're not confident in your answer, put it in your calculator, double check, because that's basically like you're grading yourself. You're seeing if you did it right or if you made a mistake. Our problem here says negative 2 4/10 minus 12 8/10. Remember that when we have subtraction and negatives involved, sometimes we like to rewrite them, and a lot of you will call that keep, change, where we rewrite our subtraction to be adding the opposite, because that's the same thing. Subtracting and adding the opposite are the same. So let's make it pink. That's a pretty similar color to red. Now that we've done that, it looks a little bit clearer, and we can see that because we have two negatives, we're going to add them and keep it negative. And when we do our addition, once again, I encourage you to do it by hand, but then you can use a calculator to double check if you're not sure. We get negative 15 2/10. And that's it. That's our answer because we've now found out what x is. X is all by itself, and we've discovered it's equal to the value negative 15 2/10. One more thing before we move on to the next one is if you didn't understand why I was allowed to change that to adding the opposite, if we have a number line here, this is 0, these are our positive numbers, these are our negative. If we're starting at negative 2 4/10 and we're subtracting 12 8/10, well, subtracting means we're going to continue to go in that direction to the left. We're going to continue to get deeper and deeper into the negatives. And so we're just adding that on, but we're continuing on the negative side. So hopefully that helped if that part confused you. Okay, let's try number 2. Number 2, solve y minus 15 3/10 is equal to negative 8 7/10. What is the solution to this equation? All right, I don't have any of those double negatives there. I don't need to simplify anything first. This is pretty straightforward, so we can start solving. Well, in order for us to isolate our y, in order for us to get our y by itself, we need to move that minus 15 3/10 to the other side. We can do that by doing the inverse. So the opposite of subtraction is addition. So we'll add 15 3/10 to clear that out. But because it's an equation, remember that seesaw weight, we have to keep it balanced. So we also need to do that to the other side. When we have a negative and a positive, those zero out. That equals 0. That's why we did the inverse. It now is gone from that side, and we're just left with our y. All right, once again, we need to be careful with our negatives because we have a negative 8 7/10 plus 15 3/10. When you're adding, if the signs are different, you have a negative and a positive, it's really like you're subtracting. It's really like you're taking away because that negative says, I'm taking this away. If we look at this like money, you have $15.30, but now you're spending, you're taking away $8.07. So our answer is going to be smaller. It's going to be less. So 15 3/10 minus the 8 7/10 gives us 7 23 hundredths. And again, please try to do that on your own, but if you need to double check in a calculator, of course, you can do that. All right, problem 3. Solve negative 2 4/10 m equals negative 4. What's our solution? Another way of saying what's our answer. This one looks a little tricky because I'm not quite sure what's going on here. Well, remember that our goal is to get our variable by itself. So in this case, the m. So in order to do that, we need to do the inverse. It's important for us to know what's going on between that negative and 2.4, or I'll just say it easier, that negative 2.4 and the m. Well, remember when you have a number and a variable side by side like that, it means they're being multiplied. And I'm going to use parentheses instead of a dot for multiplication because I don't want it to get confused with the decimals. So if you ever need to rewrite it to make it more visual to you that it means multiplication, do so. Well, now that we recognize multiplication is going on, we need to do the inverse in order to solve. The inverse of multiplication is division. We can divide both sides by that negative 2.4. When we divide the same thing by itself, so negative 2.4 divided by negative 2.4, we're just left with 1. But that's okay, because that means I'm left with 1m. And that's what we wanted. We want to know what this one variable means. Now, when we do the division on the other side, when you're multiplying and dividing, if the numbers have the same sign, your answer will be positive. If they have different signs, your answer will be negative. So 4 divided by negative 4 divided by negative 2 4/10 as a decimal would be negative 1 6 repeating. Or if we were to turn that into a fraction in fraction form, that would be negative 1 2/3. Oops, that's a bad looking 3 there. There we go. It's a little bit cleaner. Actually, wait, I made a mistake. What mistake did I make? Yeah, it wouldn't be negative. It wouldn't be negative because remember what I said and then I didn't listen to myself? That if you have a negative divided by a negative, it's a positive. So we can either change those into positives or delete them right there. So our answer would be negative 1 6 repeating, or in fractional form, 1 2/3. And I think I said negative again. Oh, so sorry guys if I confused you with that. My apologies. But a negative divided by a negative is a positive. So we have a positive answer. All right, let's move on. All right, we have 2 more problems because remember I said we were going to do 5 total. So problem number 4, solve x over 3 equals negative 0 and 1, negative 0 and 1400ths. What is the solution to this equation? All right, first thing we need to remember, just kind of like with multiplication, we need to remember the new ways that we show multiplication. Same goes with division. This right here is showing us x divided by 3. Because fractions are a way of representing division. If we even think about our symbol that you use for division, those 2 little dots are just replacing numbers. So we still have that line in the middle. We're just saying x is being divided by 3. So that's important. That helps us out because that allows us to see, okay, well, if division is what's happening, I need to do the inverse of that, which is multiplication. So we would multiply both sides of our equation by 3. When we do that here, I'll kind of work it out for you. That's like we're saying 3 over 1 times 1x over 3. That would result in 3x over 3. 3 divided by 3 is 1. So that just lands us with 1 single x, which is what we were working on, what we wanted. You don't have to show all the steps, just kind of wanted to prove to you why it works because I usually get that question. But now that you understand that, you can just recognize that, hey, I'm doing the inverse, I'm doing the opposite. They cancel out and we're just left with our x. Now we need to multiply on the other side. When we're multiplying and dividing, same sign equals positive, different signs equals negative. So this time our answer really will be negative because we have 1 negative number, 1 positive number. And when we multiply that out, 14 hundredths times 3 is 0.42. So 0 and 42 hundredths is our value for x. All right, last but not least, number 5 here, b plus, and then in parentheses, a negative 1.8 equals negative 4 and 25 hundredths. Kind of like the first problem we started with, if we look here, I can see that my negatives are just grouping, I can see that my parentheses are just grouping the negative with our decimal number because there's nothing on either side of it that's being multiplied. I don't have a number or a variable that's smashed up right next to the parentheses, meaning that it also means multiplication. So all it's really doing in this case is just telling us that that 1 8/10 is a negative number. And another way you could even look at this is remember that subtraction is the same thing as adding the opposite. So we could even rewrite it with a minus sign. We would be allowed to do that. We could do keep, change, change in reverse because subtracting and adding the opposite are the same thing. All right, now that we've done that, because it's subtraction, because it's a negative, whichever way you want to look at it, the inverse of that, the opposite is adding. The opposite is a positive. So we would add 1 8/10 to both sides. Because we've done the inverse, that zeroes out, and we're left with b equals. Be careful here. We have a positive and negative that we're adding. So remember when you're adding, if the signs are the same, you add and keep the sign the same because you're continuing down the same side of the number line. If your signs are different, like we have here, you're technically subtracting, you're technically taking away, and then you keep the sign of the heavier number. So we can subtract 4 25/100 from 1 8/10. And because the 4 25/100 was heavier, there's more of them. That means our answer will be a negative 2 45/100. All right. I hope this helps clear up some of your questions that you maybe had. If there's any assignments, whether it's IXL or whether it's a quiz or a test that you'd like to go back and redo, please do so. I hope this was a good review and study session for you to clear things up. But if you have more questions, please let me know, and I will be happy to help. All right. Have a great rest of your day. See ya.